let's look at an application involving a hyperbola. So in this example, we're looking at the thrust nozzle of a rocket. So that's kind of where the fuel comes out at the bottom of the rocket. In this case, for this example, we want this thrust nozzle to have a hyperbolic shape. So it should be shaped like a hyperbola, especially if you think about rotating it around. So the cross section would be a hyperbola. To allow the fuel to enter the nozzle, the top must be 5 meters wide, but it needs to narrow down to the narrowest part, which only can be 1 meter wide, and that must be 2.5 meters below the top of the nozzle. If the entire nozzle is 4.5 meters tall, what is the width of the nozzle at the bottom, at the base? So we have an illustration that accompanies the problem here. So again, we see a hyperbola shape in here. It's hyperbola's two curves opening to the left and to the right. So that would be a horizontal hyperbola. But the hyperbolas are cut off at the top and the bottom. So the distance between the endpoints of the hyperbolas at the top is 5 meters. So that's sort of the width of the top of this hyperbolic shape. The narrowest distance, so the closest that these two hyperbolas ever get, is 1 meter apart. And that 1 meter narrowest distance is 2.5 meters below the top, below the 5 meters. And I know the whole shape is 4.5 meters tall. Okay. So kind of what we're looking at here is we want to figure out the length of the bottom side, that bottom edge. So to do that, we're going to want to figure out an equation for the hyperbolas curves. To find the equation, again, just like we've seen with other examples, other applications, this particular problem, I just have measurements, so I need to figure out where am I putting that picture, where am I locating it on the XY plane? Where's the origin? Because I need to know where the origin is so I can figure out what the values of X and Y are. Okay. So usually the easiest place to put the origin, like we saw this with ellipses, is put the origin right at the center of the hyperbola. And again, the center is along the narrowest little segment, line segment. So that's that 1 meter line segment. That's actually the transverse axis. The transverse axis is the line segment, but the narrowest line segment, and that's between the two vertices. So the vertices are at the endpoints of that 1 meter line. The center, I'm going to put as the origin, is right in the middle of that one. Okay, which means I now know what the vertices are. So if the whole distance from one vertex to the other vertex is 1 meter, that means each of those vertices is 0.5 meter from the center. So I could say one vertex is at 1/2 0, and the other is at a -1/2 0. Okay. I may not necessarily need that, but I do know what letter in our equation comes from that transverse axis. I know the length of the transverse axis is, in this case, the transverse axis is a length of 1 meter, and that transverse axis is always equal to 2a. And so if I isolate the a, I'm going to get an a value of 1/2. So I know the a value is 1/2. I don't know b. I don't know c. And I don't really need c to write the equation. I do need to find b, though. So how could we find b? Well, what's the equation look like? Assuming the center is at the origin, do we have a horizontal or a vertical hyperbola? Looking at the graph, again, the two hyperbolas curves open to the left and to the right. So I would say we have a horizontal hyperbola. And if you have a horizontal hyperbola centered at the origin, then you're going to have x squared over a squared minus y squared over b squared, and that will equal 1. I already know the a value is 1/2, so that means I would have x squared over a 1/2 squared minus y squared over b squared. and that's equal to 1. So I need to find b to find the equation, and then once I find b, I can use that to figure out the length of the bottom side. Well, in order to find b, I don't know anything about the foci, which would tell me c. So I can't sort of use that c squared equals a squared plus b squared, right? I can't use this equation because I don't know what c is. I don't know where the foci are. If I knew another point on one of the curves, I could use that to solve for b. So if I knew an x and y coordinate, I could plug those into the equation and solve for b. And it turns out we can actually figure out one of those points. Let's look at the very top right corner of our drawing here. If the origin is in the middle, then how far is it from the origin to the top? I know that's a distance of 2.5. That's a y value for that top corner. So 2.5 is the y coordinate. Well, what's the x coordinate? Well, the center has to be in the middle of that 5 meters. So that means half of 5 meters, which is also 2.5, would be the x coordinate. So I have an x coordinate of 2.5 and a y coordinate of 2.5. So if I plug in an x and a y value of 2.5, we're going to have 2.5 squared divided by a half squared minus 2.5 squared over b squared is equal to 1. If I compute this first fraction, 2.5 squared divided by a half squared, it turns out that that's just equal to 25. So 25 minus 2.5 squared over b squared is equal to 1. I could then subtract 25 from both sides. So I would have a negative 2.5 squared over b squared will equal a negative 24. So how do I solve for b from here? Let's multiply b to both sides. So I'll have a negative 2.5 squared equals a negative 24 times b squared, and then we can divide both sides by the negative 24. So we're going to have a negative 2.5 squared divided by a negative 24, and that is equal to b squared. So b squared will equal roughly 0.2604. And I'll just round it to 4 decimals. We could keep a more precise answer if we wanted to, but that's enough. So my equation now, if I plug that in for b squared, I don't even need to find b, I just need b squared. X squared over, well, what's a half squared? That's 0.25, right? So I'm going to have x squared over 0.25 minus y squared over this 0.2604, and that's equal to 1. So I have the equation. How do I find the length of the bottom side? Well, let's do the same thing that we did to find this top right corner. Could we find an expression for the bottom right corner? Okay. If I were to extend this center line down from the center to the bottom side, do I know its length? Well, I know the whole thing, the whole nozzle is 4.5 meters tall, and I know the top part of it is 2.5 meters tall, which means the bottom part is only going to be 2 meters. That means that this is going to have a y coordinate of a negative 2. And then I want to try and find the x coordinate because I don't know this distance here. I don't know what that distance is. And if I can find x, then I could double it because this is also x over here. So if I find x, I can double it and get the entire distance. So let's plug in a negative 2 for y into our equation, and then we'll plug in x. We'll just leave x. So x squared over 0.25 minus a negative 2 squared over 0.2604. And that's equal to 1. So x squared over 0.25 minus, and we can just take all of that and plug it into a calculator. So negative 2 squared is 4, and 4 divided by that 0.2604 is going to be roughly 15.36, and that all equals 1. If we add 15.36 to both sides, we'll have x squared over 0.25 equals 16.36. We could then multiply that by 0.25, and that will give me roughly 4.09. And then we take the square root of that, and that will give me 2.022. And remember, that x value is from the center to the right. It's also from the center to the left of that bottom side. So if I double that value, I will get 4.045 meters. So that's roughly how long the bottom edge of that nozzle needs to be.